Well, how does this look different than x plus 2 squared or x minus 5 squared? Because I've seen lots of people do this, and this is a mistake, by the way. Well, let's square this and just say squared minus squared like that. Okay, well, that's no problem. Well, this is very different. Okay, this is completely wrong. Okay, same thing here. You cannot square across plus and minus. Okay, plus and minus and squares are not compatible. This cannot be done ever. Okay, it never works. There's a good reason for this. Because when we square something, by definition, we get a square shape. Okay, so when I do x plus 2 squared, x plus 2 gives me a square shape. So I have x plus 2, x plus 2. It's the same length and width. The shape I get is a square, and it's all symmetrical. Okay, I've got symmetry across here. Same with this. Okay, so this is not, we're not going to just have two squares like that. These are not the same. Okay, this is a square, this is not a square. If we just look at these two parts, x squared plus 4, two squares do not make a square. Okay, so this can't be done. So when we square a binomial, we can never square the individual parts. Okay, so same thing with the x minus 5 squared. If I square x minus 5, I need a square. X minus 5, x minus 5. I'm going to end up with x squared, positive 25, and I have to have these symmetrical parts to make it square. Without these two parts, I don't have a square. Okay, I have two squares that don't make a square shape. And by definition of squaring, this does not work because squaring gives us squares. That's how we define squares, our power 2. The other thing we can remember is, I think I've mentioned this before, squares and plus and minuses are not compatible. So plus and minus can mix with times and divide. That's okay. Times and divide can mix with squares and square roots. They can mix together. These do not mix together. Okay, squares and square roots cannot interact with plus and minus. To do that, we have to multiply. So we have to show length times width, or FOIL, to FOIL out these squares. We do not ever apply squares across the plus and minus. Okay, so why is the difference of squares look different than these? Well, first of all, these are squares. This is a square shape. Okay, these are square shapes. Differences of squares are not square shapes, so they are not the same thing. They're completely different. They have these two parts missing, which means that we have to get rid of those two parts. And to get rid of the two parts here, one positive, one negative, we need opposite symmetry. That's why we need this difference of the conjugate pairs. So these shapes are not square. If I put two squares together like this, it could, in this argument, works not just for a squared minus b squared, but also works for a squared plus b squared. But for our context, we're factoring a squared minus b squared. So if we take the a squared and we take away this b squared, we can show it as negative area here, or we can just take that away. This remaining shape, okay, which I'll highlight in yellow, so if I take the big square and take away b square, this shape is not a square. Okay? So we cannot express this, factor this into a square, or we cannot square root this and say that's a minus b squared. Okay, that just doesn't work. A squared plus a plus b all squared is a square shape. Okay, like I showed you up here, same thing. Here, a plus b all squared is a square shape, because when we square something, by definition of squares, we get a square shape. So what shape is this then? Well, if I do a plus b times a minus b, because that's how it factors, this factors into a plus b times a minus b. Well, that means that one side is longer than the other. It's a rectangle, so it's just a rectangle. And we can show this and do this. If I just there's a few ways to do this, but I can split it along this diagonal. And I can take this piece here. Okay, I'm going to take that piece. I'm just going to put it on its side like this. Okay, so there's my A and B. Okay, and in fact, that length here is going to be A minus B. Okay, because it's going to be this length here, from here to here. So we took the length of A, the big square, and took away that little square length. Okay, so there's my A minus B along here. That little bit there is going to be my B. I'm going to take that same shape, take this piece up here, and I'm just going to do that, and it'll just fit nicely into here. I just drew this a little bit long, but okay, so it's going to look like that. That little bit here is B. This little bit here is A minus B. This length is A, and this length is A here. Right? This is going to be A here and A here. Okay, length along this big square. Now you can see then we can put those two pieces together as a rectangle, and the length is going to be A plus B, and the width is going to be A minus B. Well, there it is. We have our length and width. Okay, and it makes A squared minus B squared makes a rectangle, and it makes a rectangle with length of A plus B, A minus B, which is our conjugate pairs.